The planner approach helps to expand the usage of design space exploration strategies. These studies usually generate a lot of numbers which are meaningless unless you give them a proper interpretation. A decision intelligence approach, which uses advanced data analysis and visualization tools, is required to get valuable insights. ModFrontier answers to this need with a multitude of design charts and advanced tools for sensitivity analysis, multi-criteria decision-making, clustering, and so on. Danilo, how has this simulation data analytics technology evolved in the latest releases, and which is the direction for the future?
For what concerns data analytics, Dario, the main development driver has been helping our users to manage the complexity of the data that are typically produced by an optimization run. The complexity is not only the number of data, the amount of data that you get at the end of the optimization run, but also the number of variables that you are requested to manage in your workflow by the modern industry, by the complexity of the processes in the modern industry. I would like to mention two design space tools in this context, the sensitivity analysis and the clustering tool. The sensitivity analysis is a very effective tool that lets you to understand the relationships between the design inputs and the responses that you collect from your solver typically in the workflow. The sensitivity analysis tool is very powerful because it helps you to reduce the size of the problem by exploiting the correlation between inputs and outputs. The clustering tool, at the same time, is very powerful because it lets you to group similar data in similar groups so that you can understand the relationships between the different groups and take advantage of this in the information that you get at the end of the optimization run. For the future, we have already started, by the way, to make more homogeneous the different tools that we have in the design space. Now they have a common UX for the wizard, and in the future we are also thinking to give them a dashboard-based approach. In this dashboard, the user can customize, the user can decide the type of charts that he wants to see to get the better understanding of the data itself.
And you know, in our SPDM platform, usually the design process involves many stakeholders that needs to access the product performance metrics. So in the end, there is the need to share the simulation results. And what Danilo mentioned right now is also available into Volta to scale up and to make everybody collaborate on top of the same platform. So that Volta was born with the collaboration in mind, and data analytics and post-processing of the data generated during the simulation is a collaborative task too. So in the end, after the run, you really have to interpret the data to understand it in order to get useful information out of it. And it's the final step to take the decision. So in Volta, we have a collaborative web environment, which is called Volta Advisor, that allows you to interpret the data, to plot it by means of many different dashboards. You can plot the data, visualize the data in different tables, in charts and radar, or you can also insert notes in order to collaborate with your colleagues and let them understand what you have done during the post-processing. And then lately we introduced also the images and the 3D models. And on this topic, one of the biggest change of the next releases is the 3D model analyzer. The idea is that when you perform the CAE simulations, you should be able to perform the post-processing on the web too, so that with the 3D model analyzer, you will be able to open the CAE model, post-process it, create section planes, and visualize scalar results, vector results, in order to fully understand the model and what the simulation looks like.